All right, my children. Good morning, everybody. Good. Just now, huh? Yes, I could hear my man. Good morning, everyone. Happy New Year. Happy New Year to everybody. Right. No, not this. Here we go. All right. I hope everyone could hear me good. Good morning, Cyan. Right, give me a second. All right, guys. How has this term treated everyone so far? I know everybody back out to school. Well, at least the majority of people are back out to school on a rotational basis. So, how is it going? How everything going so far, everybody? It's been a while since I saw you guys. A good while. So obviously, I had to get plenty work done moving forward. And if I understand, there are a couple of you all who know starting. Now, as usual, I will always recommend everybody to go back into the previous videos you have under the playlist and watch back the video. All right, I think this is number 7. So go back and watch numbers 1 to 6 so that you will have a clearer understanding of what we're going on to. Now, today, my plan is to get a little bit of feedback from all you. And I have intentions of starting something called coordinate geometry with you guys today. So, tell me what all you would like, what topics you all would like me to cover. I will take note of it. If something is way off track, I'll just make an independent video on it. Guys, I'm not putting it up on the channel. So, give us some feedback now. What topic you all will want for me to do in the future? My plan today is to start something called coordinate geometry. So tell me. While I'm waiting, set up in the meeting, right? Now, I really do hope the term has been very, very kind to everyone. Very, very kind. Start to do set theory. Okay, that is no problem. Right, set is a very, very simple topic. I'll cover with you guys very, very soon. All right, so we have no pressing matters to do set theory right now. Probably when I finish the coordinate geometry section. We can do set theory, which will be like 1 or 2 classes, and then we will go on to quadratics. Okay. Now let me get a little thing started here now. Now I want you all to at least try to follow along with what's going on, right? Now over here we have we coordinate system, right? And we coordinate system, we call this fella here our XY axis. All right, all this will cover graphs cyan. Now on the XY axis, we refer to that as our Cartesian plane. So the Cartesian plane refers to the XY axis. Points can be plotted on the Cartesian plane or the XY axis, and they can be read from the Cartesian. Now, when I say read, I mean we can actually determine the coordinates of a point. And the coordinates of a point are the x coordinate first and then the y coordinate. So, if you all tell me in the chat, if I actually put in a point here and I say, yo, that is point A, what's going to be the x coordinate of A? And what's going to be the y coordinate of A? Well, the x coordinate of A is going to be 4 because this is my x axis. The y coordinate of A is also going to be 4. So the coordinates of A is going to be 4, 4. If no Kelly, you could always take this down and watch back the video afterwards if you want to. If I have an x point here, this point B has x coordinate 2 and y coordinate 1. So we read this point 2, 1. If I have a point C, C has an x coordinate of -3 and a y coordinate of +1. So if I were to put the values here, 2, 1, -3, 1. So try it for yourself. I'm gonna put a couple points here. Try it for yourself. When I come back onto GeoGebra, I will expose the coordinates of the points. So try and read off what is this. You could pause the video if you want. Try and read off what is this. What is this? What is this? And probably this one here. Right? D, E, F, G, and H. Try to read them off. When I come back on GeoGebra, I will show the values of the coordinates. So this is important. A point, if I go back to GeoGebra, a point consists of 2 coordinates. So all of these things are points. A is a point, B is a point, C, D, E, F, G, H, all of those are points. And if you realize, every point has an x coordinate and a y coordinate. Now, a straight line can be drawn by joining any 2 points together. Any 2 points together, you can draw a straight line. Now, that straight line is called a line segment. Now, just a little note, a line segment is just part of a line. All right? So, if I would give you, this is a line here. If I say this is a line here, and this is the line AB, and I say I take another piece of this line, or I labeling piece of this line C and D. CD is a line segment of a bigger line, AB. Similarly, AB could be a line segment of a bigger line if I extend this so and I extend this so. We'll come to a little better understanding of line segments now. So, as promised, I'm going to show you all the coordinates of all of these points. Nice. So you could have done your own work, check and see if you get the points correct. Now, if I wanted, I could say, well, here was the scene. I could actually connect any 2 points together. So if I connect the point A to B, well, brother man, we form a line segment AB. If I connect C to D, again, we form a line segment CD. Now, if I wanted, I could have drawn the entire line for any of these line segments. But what do I mean when I say that? Let's take back a look at AB. So instead of drawing the line segment, I'm going to actually draw the line. The line passing through A and B will be that. And if you realize that line right long, he just keeps on going on and on and on and on. That's the properties of a line. A line goes on forever in both directions, right? Going all the way up and going all the way down. However, a line segment does not go on forever. A line segment has a start and an end. So again, I can draw the line segment E, F, and then G, H. Now, each of these line segments have particular properties about them. And they have properties that we can actually calculate. One of the properties is called the gradient. So the gradient of a line is a physical number that tells us how steep a line is. Now we can calculate this number a number of ways. We have a couple of formulas we can use to calculate the gradient of a line. We need a line first to calculate a gradient. And if memory serves me correctly, a straight line has 2 points, start and the end. So to calculate the gradient of a line, I need 2 points. Any 2 points on the line, any 2 points. So just a little visual representation of gradient. As the line gets steeper and steeper and steeper, the number that represents the gradient increases. So if I give you all a better illustration here, look at the line AB. The line AB will have a gradient represented by some number. And in this case, the number is 1.5. Now, if I decide to increase the steepness of the line, look what happens to the gradient. So if I increase the steepness of the line, the gradient is increasing. Yeah? I'm increasing the steepness. I don't care if it's shorter, if it's longer, I'm just increasing how steep the line is. Obviously, the reference will be from a horizontal perspective. Okay? So if this is my reference here, as the line gets steeper and steeper and steeper and steeper, the gradient gets bigger and bigger and bigger and bigger. Similarly, if the line gets less steep and less steep and less steep, then the gradient gets smaller and smaller and smaller. So let's put back our point where we found it. Let me change the point. I will put that point, right? I will put the point. We go, I'm just trying to figure out because I know one of the calculations. Okay, cool. I can work with that. So do you all understand the concept of gradient and what it represents? It just represents how steep a line is. Now, all of these lines will have a particular gradient. Now, obviously, they won't have the same gradient because they are all drawn at different angles. They all have a different angle from that horizontal reference point. All right? So we need to learn how to calculate the gradient. Now, good morning, Gabriela. To calculate the gradient of a line, one particular way to do it is with a formula. And the formula is given by y2 minus y1 over x2 minus x1. Now, when we see this y2, y1, x2, and x1, we start to wonder, well, what is that? Well, what is that? What is y2, what is y1, what is x2, what is x1? Again, if memory serves me correctly, my children, I need 2 points to calculate the gradient of a line. y2, y1, and x2 and x1 is just a little representation so that you can identify different points that we are using. Now, I'll use back this same example. A is 3, 6. So A is the point 3, 6. So I just changing the values of some stuff here. And B is minus 1, 5. B is minus 1, 5. And that is the line AB. Obviously, again, this line will have a particular gradient. We have to calculate it. So A has coordinates 3, 6. B has coordinates minus 1, minus 5. Now, your knowledge of adding together negative numbers, it plays a big part here. If you don't know how to add together negative numbers, I recommend you go back and look at some of the previous videos. So if I were to calculate the gradient of AB, I first have to label the points x1, y1, and x2, y2. Now, you might ask yourself, sir, but which one is x1, y1, and which one is x2, y2? It doesn't matter. As long as x1 is there next to y1, you're good to go. And as long as x2 next to y2, again, you're good to go. So, if I were to focus on the red working will correspond to the red labeling in the points. So, my red working says that x1 is 3, and y1 is 6. And x2 is minus 1, and y2 is 5. Now, focus on the formula. Formula states the gradient. Gradient is symbolized by common m, by the way. Forget to tell you all that. Symbolized as common. The gradient is given as y2 minus y1 over x2 minus x1. Well, from a red working, y2 is 5. Okay, I'll write down 5. Take away, y1 is 6. No problem. 5 take away 6 on top. Denominator time now. x2 is minus 1. No problem. Put in your minus 1. x2 is 3. So it's x2 minus x1. So it's minus 1 minus 3. When you minus them, 5 minus 6 will give me negative 1. Minus 1 minus 3 is negative 4. Minus and a minus is a plus, and I get a quarter. Reset now. I did say it doesn't matter which point is x1, y1, and x2, y2. So the green working now will correspond to me making the decision to label my points x1, y1, and x2, y2, which is different from the first set of working. So for the green working now, x1 is minus 1 and x2 is 3, y1 is 5 and y2 is 6. So make sure you're following with me, right? So the formula says, yo, y2 minus y1. Let me figure out what y2 minus y1 is. y2 is 6. Here, y2 is 6 based on the green working. y1 is 5 based on the green working. Alright, 6 minus 5 is good to go. Denominator time now. x2 is 3. take away, x1 is minus 1. Now, I've seen this mistake occur plenty times. Students will say, well, you know, it's 6 minus 5 over 3 and x1 is minus 1. Mistakes were made. Remember, it's always some quantity take away some quantity over some quantity take away some quantity. This quantity is y2 and this quantity is y1. So looking at my green working, y2 is 6 and y1 is 5. Looking at my working, x2 is 3 and x1 is minus 1. So just make sure you don't make those mistakes, right? Well, 6 minus 5 is 1. 3 minus minus 4 becomes 3 plus 4. 3 minus minus 1 becomes 3 plus 1, which is 4. Now you realize I get the same gradient, regardless which way I label the points, right? And this happens every single time. Now, challenge yourself, guys. Just challenge yourself. Calculate the gradient of CD. Calculate the gradient of GH and EF. And take down the points. Sorry. Take down the points. When a little later in the video, I will reveal what the gradients are. A little pointer here, and make this big and bold in your working. Right? In your notes. Sorry. In your notes. Always express gradient as a fraction. Never express gradient as a decimal. And there's a particular reason I say that. Always express your gradient as a fraction. Never ever convert it to decimal form. It's extremely important to do that. And you'll see the importance a little later on in this topic. So like I said, challenge yourself, calculate the gradient of all of these lines here. We already calculated the gradient. So calculate the gradient of the line. See what you get. Now, we just now established that the gradient of different lines are indeed different. Now, there are a number of different types of lines that we know of. We know that there are lines drawn diagonal, right? And the diagonal lines, they can be in two directions. And the direction is extremely important. Extremely important. We have horizontal lines. We have vertical lines. Then we have parallel lines and perpendicular lines. And these 5, we'll call them types of lines. They have specific properties with respect to their gradients. So let's dive into the first one, diagonal lines. And we'll subdivide them into A and B. Now, if I draw a diagonal line in one particular direction, and I just give the points I need, x1, y1, and x2, y2. So, to make life a little bit easier for you all to understand, I just go in and give the points the names. Let me give the points the names what by. Yeah, let me say this A, there is B. And let me say this is P and Q. So down here will be A, B. Down here is going to be P and Q. So if I label the points in such a way where x1, y1 is U, and x2, y2 is U, and I decide to calculate the gradient of B. Well, obviously it's y2 minus y1 by x2 minus x1 because that's the formula. But y2 is Q. All right, no problem. We will write that down. y2 is Q. minus y1 is b. No problem. x2 is p minus x1 is a. Now, you're going to ask yourself, but sir, what is that? What is q minus b and what is p minus a? Now, these examples here, they just illustrate a concept of gradient with a line. And the concept uses abstract algebra. So if I look at my graph, q take away b, obviously from the graph, q is definitely bigger than b. Q is at a higher point on my y-axis, so therefore q is bigger than b. So I have a big number, take away a smaller number, it's always going to be positive. 10 minus 2, 15 minus 6, 20 minus 19. All of these scenarios where I have a bigger number, take away a smaller number, will always give me a positive number as my result. So we have a positive number here. P minus A now. Well, P is smaller than A. Given that P is definitely smaller than A, that means I have a small number, take away a bigger number, I will always get a negative number. Again, if you don't understand these concepts, go back and look at some of the previous videos. So P minus A is going to give me a negative number every single time. I have a positive number over a negative number, I am going to get a negative number. Now, if I show you one case for a particular line, I show you all cases for a particular line. I can make a conclusion and say, any line drawn in that direction has a negative gradient. Any line. And we can use this as a guide to know if, well, is my gradient correct? So if I look at it here, right, and I show you that, we now say any line drawn in this particular direction has a negative gradient. So ask yourself, which of these 4 lines is drawn in this particular direction? All right, let me put the points next to the labels next to each point so you'll see it. Nice. So, I mean, if you answer it already, the only line drawn in this particular direction is GH. So GH is going to have a negative gradient. And if I check the gradient of GH, you'll see, I'll delete one of them, the gradient is negative. It's negative 1. So I'll just reveal one of the gradients. I'll leave it there. Go ahead and calculate it and show that the gradient is negative 1. If I decide to do the same thing for the next type of diagonal line, which is a line drawn in that kind of direction, I perform it using the same knowledge. So A, B, x1, y1, x2, y2, the gradient is x2 minus y1, sorry, y2 minus y1 over x2 x1. But in this case, y2 minus y1, well, I'm seeing here y2 is bigger than y1. Okay, if y2 is bigger than y1, when I take them away, I get a positive number. Cool. x2 minus x1. Well, again, if x2 is bigger than x1, then x2 minus x1 is also a positive number. So I get a positive number over a positive number, which will also give me a positive number. So I can also make a conclusion here. And I can say any line drawn in This particular direction has a positive gradient. Again, we can go into GeoGebra and we can see it happening. If I were to determine the gradient of CD, positive, AB, positive, and FE, right? So these three lines are going to have a positive gradient. Now, just to illustrate the first example, I think I drew the point wrong now looking back at it. Yes, I did. -1, 5 is this point here. That is -1, 5. Okay? That is the point AB, which is -1, positive 5. And we calculated the gradient of AB to be a quarter. 0.25 is a quarter. Unfortunately, this application I use, it does not give you the answers in fraction form. It always converts it to decimal. But I'm telling you guys, make sure and put your answers in fraction. Now, I'm putting this one back down here, -1, -5. Good. So now you will actually have each gradient of each line. So you can probably pause the video when you're doing the work and make sure you get these gradients when you come out. I'm going to change up the gradient for this one here and see if we get 5. And change up the gradient for this one here. See if we get 0.5 or a half. Actually, I'll change this one to be a negative gradient. Okay, cool. And I will just change this one to give you a kind of mad answer, 0.429. Now, if you get your fraction, just type in the fraction, bam, 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 in your calculator and see what the decimal equivalent is, and you're going to get negative 0, which will be an approximation. Now, apart from this vertical, this perpendicular lines, we have horizontal and vertical lines. And these will be the last two lines, and I'll just touch on parallel lines before the end of class. A horizontal line, well, is a horizontal line. If I draw a horizontal line, and you pay close attention, pay very, very close attention, a horizontal line has the same y coordinates. Again, a horizontal line will have the same y coordinates everywhere. Line. And, well, brother man, we could illustrate it here. If I draw any horizontal line, bam, bam, any point on this line will have a y coordinate of -8. Give me 1 second, guys. Sorry about that, guys. Nice. Yeah, so back to the horizontal lines business. Any horizontal line will have the same y coordinate. So if I put a series of points on these lines, and obviously it's going to be easy points we can read off. And then I say, well, what is this in, brother man? Show the values. Show the values. Good. -8 is my x, corresponding y is -8. -6, -8. -4, -8. -2, -8. 0, -8. So you see, all of my y coordinates are the same thing. This is important. Since all my y coordinates are the same thing, well, y2 minus y1 will turn out to be 0. x2 minus x1 is going to be some positive number, but at the end of the day, 0 over anything is 0. So I can make this general conclusion about horizontal lines. All horizontal lines will have a gradient of all of them. Lastly, for today, vertical lines. Similar to horizontal lines, but a bit different. Vertical lines has the same x coordinate right through. Well, if they have the same x coordinate, then x2 minus x1 is going to give me 0. And here, I have division of 0. When I have division of 0, this is infinity. Or the gradient of vertical lines is infinity, or it's undefined. Right? It's either infinity or you can say it's undefined. Very, very important concept. And lastly, parallel lines, well, they have the same gradient because they are drawn at the same time. So take it upon yourself, guys, and calculate the gradient of these 3 lines for me here. A is minus 2, 3, B is 6, 7, and C is minus 1, minus 4. Now remember, if I calculate the gradient of AB, I'll use the points A and B. If I calculate the gradient of AC, I'll use the points A and C. If I calculate in BC, I'll use the points and C. See what answer you get. And the next time I meet you guys, I'll reveal the answers, and we are going on to the concept of perpendicular. Right? So, everything is there for you to take down. You can pause the video if you have to. Take it down, practice your work. Practice makes perfect. And I'll see everybody next week, Saturday. Same place, same time. Stay safe. Like, subscribe, comment if you want to know anything. See you guys next.